Okay, so if you look at question one is something that is looks very simple. I already taught you this, and in some of the videos that you watched on the YouTube channel, you already have access to that. But anyways, I'll still explain how to go about it. So I'll answer one. So let's choose the one that you want me to answer. Should I answer A, B, or C? So if you don't know how to remember these laws, you're supposed to know. I also explained on the laws under set theory. If you don't have access to that, I can allow you to have access. You can just let me know after the class. Okay, so basically, if you talk about De Morgan's laws, we said A intersection B in brackets. So if there's a complement outside there, the basic idea is you expect everything inside there to change. A will become A complement, the intersection becomes union, and then B becomes B complement. Of course, the opposite is true. If you have union in between as well, and then a complement outside, you expect that the sign also become intersection in between. These are the two De Morgan's laws. Very easy to remember. Then the other laws that I talked about are associative laws. Associative deals with three sets. So if you have A intersection B intersection C, and then again you have A intersection B intersection C. So you understand that these signs, intersection or union, they are binary, meaning that you only perform it between two things. So if I say for the first part, which is the left hand side, I'll first of all begin with B intersection C, and then the other one I'll start with A and B. The result is basically one and the same. That's what associative laws tell us. Okay? So I'll prove this now for the sake of your understanding using the question that was given to us. So if you look at A, they've told us A is having those elements here. 2, 3, 4, 5. B is having 2, 4, 6, 8. C is having, we're able to see all that. Now, for us to prove, I'll only prove the first one. Whatever, the way I'm going to prove it applies to everything else. So to make sure that we have enough space, I'll just do this. Then we'll just do this. Then we can go back to our board. Is that visible on your side? So we have our question there. We need to prove this first part. So I'll rewrite that. We have A intersection, or I can just even just go direct. So we can clearly see that the left hand side is equal to what? Is equal to A intersection and then open brackets B intersection C. So what this tells us is you need to begin with what is in the brackets, which is B intersection C. So on the next step I'll find B intersection C. Now B intersection C is we're interested in what is common between B and C. If you compare B and C, what elements are common there? I can see that we've got 4 and 6 as our common elements. And then I'll proceed on the next step. We have A intersection B intersection C. So our A, I'll rewrite it as it is. We have 2, 3, 4, and 5. Now there's int for us to intersect this with B intersection C, which we found to be 4 and 6. What are the common elements between these two sets? I can only see a 4 to be the common element. So that's our left hand side. Any question on how I've simplified the left hand side? No question. So don't forget our solution. we have a 4. For the right hand side, we have A intersection B. So what is different here is what you basically get to start with. So I'll start again with what is in the brackets. My A intersection B is equal to what? The common elements between the two sets A and B. If you compare A and B, I can see that 2 is common, 4 is common. I think those are the only two elements that are common. Please, if you have a question, feel free to interrupt me. I'll be there to respond. And then we have now our C there. So in fact, let me just leave it there before I. So our intersection B has been found. Now proceed with our right hand side again. So our right hand side is equal to our A intersection B, which we've already found to be 2, 4. And then intersection with C. Our C is adding 3, 4, 5, and 6. So what I've done is I've just found the unknown, which is the intersection B, which is this 2 and 4. And then I've gone back to that stage where I now substituted this is my A intersection B and then that is my C. Now we're trying to find the intersection. The intersection tells us to get the common elements. In this case, 4 is the only common element. So for our right hand side, we're also getting a 4. Any question? So at this point, we can now conclude to say, since the left hand side is equal to the right hand side, hence what? Hence confirmed that the law is correct. So the same steps apply to the distributive laws, the other associative law where you use union. The same concept steps apply. What is important for you is to be able to remember them in case they ask you to confirm them without them writing them down for you. So if you still don't know how to remember those ones, make sure you check out the video that we have on the laws on set theory. Just go to YouTube, search laws on set theory. You'll be able to locate the video. Or even in our app, for those who've purchased set theory, you'll be able to see that topic, that video talking about all that. So on the confirming part, there are no issues. I believe so. Can we go to the second question? Or we have some concerns on the first part?
Let's move on to the second question.
Okay, so the second question is also interesting. So should I answer A or B for this one?
A.
Of course, A is having a lot of questions. I'll not answer all of them. Okay.
For question A, maybe you can even start with the last one.
Want me to start with the last one?
Yes, since you said you won't answer all the questions, maybe you can even start with the last ones, then you can go the other way around.
Okay, so there are a few things, ladies and gentlemen, that I hope you've understood from your class. Have you done this in class already?
No.
Okay, so if you did it in class and you've not understood, just go to the app. You'll be able to find this part. I explained very much in detail on how to go about this, what all these stand for. But of course, I'll mention a few basics that you'd have to. If you look at this, in a case where I have a set being represented like that, and then this is my 2, that is my 4. One thing that you have to understand is when they are open, I use curved brackets. I'll say 2, 4. So if I ask you how many elements are between 2 and 4, what could be your answer? No one knows the answer. Okay, so they are basically uncountable. We don't know how many real numbers are between 2 and 4. Okay, so we basically use this to denote. So what we are trying to say in this case is The meaning is 2 and 4 are not part of a set, but all the real numbers between the two numbers are part of a set. Okay. If I shade on one end, the meaning changes. It tells me 2 is part of a set. So we use such a bracket to denote that. Are we together?
Yes.
Okay, great. So we are now ready with first two few basics to answer the. So just to help you understand, I'll start with the first one. Even before I answer the last one, I'll answer only two questions. So not that I'll answer all of these questions. All the solutions will be available on the app under set theory, so you don't have to worry about yeah. So for A, we have -2 all the way up to 6. Now they want us to find its complement. So I explained in detail what a complement is under in if you go to the app, but it's very simple actually. So a complement of a set is just elements outside that set, but within what? But should be within the universal set. Do we understand that? So if my universal set, for example, if I can use roster form to give you an example, is having these elements, and then I tell you set A, which is part of this universal set, is only having 2 and 4, A complement is supposed to be what? The other elements that are not in A but are within the universal set. So the ones that are in the universal are not in A are what makes it A complement. So we have 0, 1, and 3. That's what the complement is. Outside the given set, but within what? Within the universal set. So we'll answer now on the number line. So on the number line, our set A has been we've been told it's from -2 all the way up to 6, as we can see. So from -2 all the way up to 6. That is where our set A is. Now notice that both ends are not shaded. -2 and 6 are not what? Are not shaded. That is our set A. Now our inverse set is the X, which has been said to be the inverse set, as we can see from the question. Now it's moving from -10, which I believe should be this side, all the way up to +10. So that is our universal set. Now they want us to find the complement. So the complement is going to be everything else that is remaining, because notice that what we have here is our set A. Now everything else that is part of the universal set are not in A is what we are now calling our A complement. So therefore, beginning from this part all the way up to the end, and again from this part all the way up to the end, are what? That is our A complement. Now, there's one important aspect that we would have to put into consideration. That is how we are going to shade. Now, notice that if an element is part of a set, it cannot be part of a complement. And if it's in the complement, it cannot be in the set. So it's either an element is in a set or it is in its complement, like we saw. Okay? Now, let's try to understand what we have. So, if we look at the way we've been given our universal set, we have curved brackets which indicate that -10 and 10 should not be shaded. So if they were using these brackets, we are going to shade the two ends. But in this case, we are not going to do so because the question tells us it was an open part, as we've seen, right? -10 to 10. So not shade the ending point. Now the other decider is this part. Should we shade these parts? So
Yes,
why are we going to shade?
because -2 and 6 are not included in set A.
Because what?
Because -2 and +6 are not included in set A, so that means the complement of set A.
All right, good, good. Do we understand what she has said? The fact that negative 2 and 6 were not shaded, it tells us they are not part of A, therefore they are supposed to be part of A complement. Does that make sense?
Yes, we understand it.
Alright, good, good. So now, to present our solution, algebraically we are going to say A complement is starting from negative 10 all the way up to negative 2. So now, notice that negative 10 is not part of the solution because we've not shaded it due to the fact that it wasn't part of the universal set. Let me show that as a well curved bracket. Negative 10 all the way up to negative 2, and negative 2 is part, and then I'll use union to combine the other side. The other side, 6 is part of the solution all the way up to 10, where 10 is also not part of the solution because of the universal set. So what is our solution there? Is there any question?
It's clear, sir.
Okay, anyone else to confirm that? Okay, we move on. Yes, please. Is it possible to do what? Kindly speak up. I can't get you.
Is it possible to simplify them further?
Is it possible to simplify them? Are you able to do that?
Whereby you use this, which is negative 10, and compare it with 6, and then you see which one is what, and then, yeah.
Okay,
Is it possible or just end here?
giving you a straight answer, it's not possible for you to simplify this. The fact is, the reason is simple. We actually don't have any common elements. There is no intersection, so we can't simplify it. We can end from here. Alright, so we can now look at the last one. So if you want to access obvious solutions, you find them in the app. Okay, for now we'll answer the first and the last one so that we can have some more time to answer the other questions as well. Now this one you have to be very careful because we have to move systematically. Okay, we have x, which is our inverse set, minus c complement. What does that mean? So I'll simplify what is inside. The other day I showed you to say if we say a minus b, a minus b is the same as what? Come on, come on, come on.
A intersection B complement.
Thank you. So A intersection B complement. Thank you. So if we say x minus c complement, it's the same as what?
X intersection C complement.
Good, good. That is x minus c. Now notice that we still have a complement outside. Not so. We've simplified what is inside, which is x minus c. It has given us x intersection c complement. Now, I'm from just reminding you what De Morgan's law tells us. I said if you have A intersection B and then you have a complement outside, everything else is supposed to change, right? A becomes A complement, intersection becomes union, B becomes B complement. So we'll do the same here, we'll apply De Morgan's law. Our x will become x complement. Let me even remove the brackets. Our x will become x complement. Our intersection will become union. Now C is already C complement. It becomes what?
Just the C.
It will become the opposite, which is a C. Is that okay with everyone? Is it okay?
Yes.
Yes.
I'll ask you again. I'll use a Venn diagram. I believe you've been working with a Venn diagram from high school. So It shouldn't be a struggle. So we understand that the universal set is the entire box, right? You may have sets inside there. Are we in agreement?
Yes.
Now, what is the complement of the universal set?
Empty set.
Set.
So, the other way I would want you to understand this is think of it in this way. We said a complement of a set are elements outside that given set but should be within the universal set. Now, if you think of it in this way, do you have elements that are within the that are outside the that are outside the universal set but within the universal set? So there's a contradiction there. It's not possible for you to have elements outside the universal set again have them within it. So it's an empty set. Or the simpler way of thinking about it is, do you have any elements outside everything? Because the universal set is everything. So if you say the complement of everything, then there's nothing that remains. Do you understand that?
Yes.
So all I'm just trying to do is simplify this for you before we basically get to go to a number line. So the complement of X, which is our universal set, is an empty set. Union C. Now, trust me, an empty set is zero. So whatever you basically get to combine with an empty set is that same thing. So if you say you have 0 plus 2, the answer is 2. 0 plus 4, the answer is 4. So union is, in other terms, is kind of an addition, right? Union is like an addition. So if you are combining an empty set with set C, the answer will be what? Set C, not so.
Set C.
Yes. Now, in other terms, if you are saying what is common between an empty set and any given set, what would you say? If we change the sign and call it intersection, what's common between an empty set and any given set? Is there anything common?
Empty set. Nothing is common.
So it's an empty set. Okay, good. Now, in this case, we have got a union. So, all in all, from whatever I've done, we've seen that this has simplified to what? To C as our final result. Any question? No questions. Okay, good. So we now have our question simplifying to C intersection A minus B. Okay, so we need to find the intersection between these two sets. Now C, we already know it, so we need to do with what is in the brackets, which is A minus B, right? So I'll draw a number line. A minus B means A without B. Do we understand that? So I'll plot my A.
Yes.
My A is from negative 2 to 6. Negative 2 to 6. That is my set. Set what? Set A. And then my set B is moving from negative 5, which I believe should be beyond negative 2, all the way up to 3. 3 is between negative 2 and 6. So what we have is we have set A. Which one is set A? The one that is down, right? This is A. That is B. Is there any part where we need to shade? Let me just try to pay attention. Negative 5 to 3 tells us negative 5 is shaded and 3 is also shaded by the kind of brackets used. And then for A, negative 2 and 6, they are all not shaded, looking at the brackets that were used. Any question with the plotting that I've done so far? Okay, seems there are no questions. So if you say A minus B, it means A without B. A without B. So we are interested in A, but we need to remove everything that is in B. So the way I basically do this is by shading. I'll just shade what is common between B and A. This is common. this entire part is region. The part I've shaded there, pay particular attention. It is what? It is common. So we need to remove it. We need to remove it from what? We are removing from A. So what is going to remain is from 3 all the way up to what? Up to 6. Now notice that that part of B is shaded. So meaning that what is going to remain is going to be an empty part. So what I'm trying to say in other terms is what remains is from 3 all the way up to what? Up to 6. Not shaded. That is our A minus B. We've removed the B from A. Any question there? So if it was the opposite, if it was B without A or B minus A, we were going to remove this intercommon part from B. So our result was going to be from -5 all the way up to -2. It would be from that point, that point. Now in that case, if you look at -2, it is not shaded. It implies that the -2 will still remain on the other side, so it would have to be shaded there. So it's like you do the opposite. Are we together? Does that make sense? Kindly mute your mic. So I've explained now how we found A minus B. We've seen that our result is from 3 all the way up to 6 for A minus B. So we found our A minus B. Now we need to find the intersection between C and A minus B. You've seen the way we've broken down this question to be a very simple question, despite it looking complicated as. So if you look at 3 and 6, where do we basically get to see our 3 and 6? From, maybe I'll start with C. C is -1 up to 8. So -1 up to 8. That is my C. Which part is expected to be shaded? If we look there, -1 is supposed to be shaded. This is our C. Then our A minus B, we've seen is moving from 3 approximately there up to 6. So we have a set from 3 to 6. That is A minus B. Now want to find what? Want to find their intersection. So we shade the common region. This region is common. So what is common is from 3 all the way up to what? All the way up to 6. Now notice that what will determine is the one that is shorter. So 3 is not shaded. It implies that 3 is not part of A minus B. So it can't be part of the intersection, because intersection represents what is found in both sets. So therefore, this will just be open like that as our result. So therefore, the answer to the last question is basically this. Are we together?
Yes.
Okay. So now, if we go back to our tutorial sheet, we can see other things that are coming after. I'm sure this you've already come across it. There's a video that is that has been shared around. So now if you move down, I want to know exactly where you are, because if you're asking the group, you don't respond. So there's an aspect of us now. There's a question asking us to describe the shaded region here. Maybe we'll do one so that you just have an idea of what we basically are supposed to do here. If you look at A, who can describe this shaded region? Anyone to describe it?
I think it could be A complement intersection B intersection C.
So that's what she has said. A complement intersection B intersection C. Okay, is that fine? So she's saying we are looking at the what is between the common elements that are in B and C, but are also outside A. Okay, that is fine. So there's not only one way to there's another way that you can give us an answer. Anyone with an idea? So I can just reverse this. Okay, I can just reverse what she has said. In that, I can begin writing my B intersection C, and then I say intersection A complement. Now, if you understand the system what we are from using, in other terms, I can say that is B intersection C. What can I put? Intersection A complement is the same as what? Anyone who has followed what we've done? Yes. Good. So I can also be right if I can say B. So in short, what we're trying to say is this B intersection C, remove A. So you remove A, you remove that part. That's what we're saying. Simple and straightforward. Now, if you look at B, very interesting, right? Very, very interesting. So, such questions you don't have to like make yourself like think too much. No. If you look at the region that is shaded there in between, it involves what? All the three sets. So it's basically A intersection B intersection C. Now, if you look at what is shaded outside, that is what? The complement of all the sets. A union B union C complement. Now, how can you combine them? You can just combine them using what? Union. That's all. Yeah, home and dry. So these things are not complicated as they appear when you look at them. So all these things, guys, if you go to the app, you'll be able to find them. All these things I've explained them there. All these things, how to convert, they are also there. The irrational numbers, even how to answer this question is also there. Okay. So you have access to even binary operations as well. So just go to the app, download the app. For the ones that are on Apple, very soon the app will be ready. In the meantime, the Android users, you can utilize this. And then very soon we'll be able to handle the Apple users as well. But we'll find a way of helping you as well. So on the app, you have access to this entire solutions to this tutorial sheet. Hopefully you've enjoyed the class. We'll end here this afternoon. We'll continue next time. Any questions in regards to what we've talked about, in regards to the app, or anything that you have to ask, you can ask right now. No questions?